please remember that this is percentage of new hair growth. So this 32% means that that's an actual 99 of the 310. So that's what you put into your calculator, 62 out of the 309. Okay, so then that gives you those z-scores and you reject and such. Okay, okay, here's on number 4. I just wanted to, this is critical that you understand how to interpret an interval, because you know that's your job. Plugging numbers is just a small part of your job. Interpretation is the main part of your job. So look here. On this problem, I had the new strain as my P1 and the parent strain as my P2. Okay. It is essential that you define right here which way you subtracted, that you have this as P1 minus P2. This is absolutely critical, because that way when you get a number like negative 0.39, so negative 39%, if you subtract and you get negative 39%, which of the proportions is higher? Good, this second one. So there's a 39%, or there's a I am 99% confident that the difference between the two proportions could be 39% higher for the parent strain. Okay. But if it's a positive 5%, then which one of these is the bigger one? Okay, so in this case here, up to 5% higher for the new strain. To me, it just is easier if you just reference the ones that are higher. Okay? So, furthermore, this is what it looks like when you have a 0 in the interval. See, it's going from a negative to a positive. That means both of them could either be higher. See, so therefore, because 0 is in the interval, there could be no difference. Okay? All right. And then we had gone over the rest of these. I do want to tell you that, just a reminder that what we had gone over in yesterday's video, number 6, that is foundational. I mean, that is what you should know in its most basic format for an interval. If you don't understand what was going on with that number 6, then you need to come and pop in and let me explain it to you, make sure you get that, because that was pretty crucial. And then you did the rest of these. Those are on the key, and those are fine. 11, and we did 12 and 13 yesterday. 14. Okay. Now, here's what I want to say about 17. So see, I just kind of add in a few little things to make sure we got some deals going on. We got some, make sure we do everything exactly right. On number 17, you're 90% sure that the true proportion of cheeses that are cheddar is between those two numbers, 79.3% and 85.1%. Okay. So somebody's claim that is 86% is entirely above that interval. The entire interval is below the claim of 86%. So you anticipate that you'd probably reject the null hypothesis of 86%. Here's the question I'm asking you. Here's the new thing I need to make sure you get. Are you allowed to officially reject or fail to reject a null hypothesis from an interval? No. This cannot be a reason for you to reject or fail to reject a null hypothesis, okay? Now, with that being said, if you had this situation, then you would say, oh, I think when I run a test, I will probably get a p-value that will cause me to reject the null hypothesis. See, this can give you an indication of what you expect to happen when you run a test. But the only license that you have, the only way that you can reject or fail to reject is with a p-value. Only way, and running a test. Okay. This was just a notation thing that I wanted to tell you. Make sure you know that the critical value can be notated as z star. Okie dokie. All right, next. Okay, here's the one, the back page that everybody kind of wants. Number 21 and 23, pretty much. Uh, 22, was there any questions just real quickly on 22? The definition basically of margin of error, it's that you know, this range that's going to make your entire interval above and below your sample.
Is there any specific way that you are wanting us to write the definition, or is it?
No, not really. I've never known the specific way that it needs to be worded to be on anything. They might say some different things and say which one of these is what explains what the margin of error is. So I just am making sure you understand what that is. Okay. All right. Here's number 21. If a result is statistically significant. All right. So now I officially have got to make sure you totally understand what statistically significant means. Statistically significant means your sample fell in the rejection region and gave you the ability to reject the null hypothesis. You have a statistically significant sample if it led you to reject the null hypothesis. Okay? All right. Now. Okay.
Do you want to know?
Not right now. All right. Okay. So number 21. Yeah, is that all right? Number 21 says, okay, a sample that you got is statistically significant at an alpha of 10%. So see, look here. Here's my sample. That means it does what? What's the definition? That means the sample is what? If it's statistically significant, it is in the rejection region. I don't know where in the rejection region. It could be here, could be here, could be here, could be here, okay? But it's in the rejection region because it was stated to be statistically significant. Okay, so the question is, would that sample still be statistically significant at the 5% level?
There's a possibility that
Perhaps, but not necessarily. Because is this sample in this rejection, the red rejection region? No, but, you know, it might be. Because I said it could be here, or here, or here, or here, or here. So it may end up being in the rejection region, but not necessarily. So not necessarily at the 5% alpha level. How about the 20% alpha level? Yes, it will definitely be in the rejection region for 20%. Okay? All right. Good? Okay, the next part, number 23, is asking you what are the critical values, okay? Those are those z-scores at this particular alpha. So here we go. Number 23A. I'm going to do these on 3 separate skills. Here we go. 23A. The null hypothesis is that the proportion is 0.4, and the alternative is that the proportion is greater than 0.4. So what kind of tail is number 23A? One tail. Which upper tail? Okay. So they say the alpha is 0.12, and since it's a one tail upper, then the size of your rejection region, the entire rejection region is in this one tail. So the size of this is 12%. The point, this is all 12%. Okay. So how do you find the critical value? That is, what is this spot here? How many z-scores? Where is its location? So how do you find a z-score? Inverse norm with what's below it. So if 12% is above it, then what's below it? Okay, so I do that, and I get 1.17, something along those lines. Now, this is not a question on the thing, but it's an extension on the, it's not on the review, but it's an extension. I want you to get this. You know where does confidence level fall on this picture? In the middle. Confidence level has happens in the middle, which is to the left of this alpha. But confidence level is a symmetrical interval where your p hat fell here, and then you make the interval, like this. So when I have to do this other side, I have a 12% here. Essentially, if I was to make a confidence level and decide what confidence level that is, what percentage then is in the middle? 76. Okay, so if I asked you what confidence is that, and that is 76, because that is what's in the middle when you have an upper 12 of 12%, which symmetrically makes the other one that. Additionally, if you know this z-score is 1.17, then this one is negative 1.17, and how could I find the area between those two z-scores? If you norm CDF, you'll get that area between those two z-scores, and that would be your 76%. Yes?
If you have a problem where it's like not equal to, so it's like both tails,
Okay.
and it tells you to use an alpha of say 12%, you split the alpha.
Yep, that's what I'm going to do on 23C. Yep. Okay, 23B is essentially the same. The alternative on 23B was a lower tail, so all 12% is in that lower tail. So how am I going to find this critical value here? Inverse norm of 0.12, and that is the negative 1.17. So same question, what confidence level would you have? What confidence level? Same thing, 76%. Okay, next and final one on this, 23C. This one is different because it is a two-tail. The alternative is P is not equal to 0.4. So that means that my alpha of 0.12, the entire alpha of 0.12 is being split between the two tails. So I'm going like this, and I've got 0.06 here and 0.06 here. Okay? So how do I find this critical value here? Inverse norm of 0.06, which I think is negative 1.55. And over here, it's positive 1.55 because it's symmetrical. If I asked you, what confidence would you have in that interval? 88%, because it's only an entirety of 12% in the tails instead of 24% in the tails. Okay? All right. Now, last thing that I need to just make sure you have a foundational understanding is that you actually say, I need you to understand the two different phrases that you say. If it's a confidence interval, is that's the conclusion in your panic model. That's whenever you say something like, I am 95% confident that the true blah, 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 whatever that is, proportion, difference, whatever, is between this number and this number, or this percent and this percent, or whatever. Okay. That's your conclusion, the interval. Versus confidence level. So if they just say, tell me what 95% confidence means, and they don't say the word interval in there, then that is where you are referencing all of these many intervals that people make, and these are all going to be 95% intervals that are made. Okay? And so 95% of all of these 95% confidence intervals, because you have a whole bunch more, in reality, will contain the true parameter. Okay? Now, I had a misunderstanding in fourth period. Will it contain your p-hat? Maybe, maybe not. But that's not what it's about. It's not about 95% of them contain your p-hat for the sample. No, it's not 95% of them contain the sample. It's about 95% of them